Good morning, ladies and gentlemen. My name is Madsen. As Martin said, I have the pleasure of being responsible for what we call technology R&D at Vestas. And I have to say I am extremely proud at representing this company because our products are saving the planet for about 45 million tons of carbon every year. We put up a turbine every third hour somewhere on this planet. And in near future we will go to nearby planets. But so far we are staying on this planet. And I guess with the rethinking and the workshops here, you will help us going to other planets. What I will cover is just briefly about Vestas, then how do we work with sustainability at Vestas, and then also how do we actually design for sustainability, because as it was said, it starts in research, it starts with the design of the product. You cannot repair downstream in the value chain or the life cycle. It starts upstream in the research and design process. Briefly about Vestas, we operate in about 65 countries around the world. We have actually more than 43,000 turbines put up today on 5 continents. We also operate them centrally, so from our R&D headquarters in Denmark, we can actually remotely supervise and operate these turbines globally. We are about 23,000 employees when we counted on Friday, representing 87 nationalities. We are still most employees in Europe because that's kind of the footprint of the wind industry. It grew out of Europe. But we are growing fast in Americas and also in Asia, with China being the single biggest wind turbine market in the world, with the US as number 2. We have 25% of the installed capacity globally of wind turbines. On offshore, we have a market share of 43% of the installed capacity. In 2010, we installed 2/3 of the projects that were installed in 2010. And what we think is more importantly is that we actually generated 2/3 of the electricity from offshore also in 2010. So that's the experience we have operating with offshore wind. As I said, we operate globally in 65 countries, so sourcing, manufacturing, sales, service, installation, and all that is a global business. So R&D is also a global business. So we are today represented in the US in 3 places. We are in Europe in 3 places also, and we are in Asia, in India, Singapore, and China. And this is purely driven by getting access to the best brains in the world. It's driven by getting access to technologies, and it's also driven by managing IPR, intellectual property rights. These are the key drivers for us being present in these locations. We are number 1 in wind energy, but in terms of energy, we are a rather small company. That means that we don't believe that we can innovate everything ourselves. We need a very strong network of partners to feed our innovation pipeline. That means also we have built up an extensive network around the world with industrial companies, with universities, with research institutes who can help us build this innovation pipeline. Some examples here are a collaboration we started with Boeing about 2 years ago on recycling carbon fiber. Boeing, Airbus, and Vestas are the 3 biggest consumers of carbon fibers in the world, and we want to be able, of course, to recycle carbon fiber so we can reuse them in our products. We also work with University in Texas and the University of Wisconsin, in Denmark, in Aalborg, and DTU here where we are, and in Asia, in Singapore, NTU, and 2 universities in China also. And on top of this, we have 60 other project partners we work with. So this is a true global network. Some of the areas we are focusing in on in the research field is material research, and it's composites, among others, because we want to make our products light as possible and as intelligent as possible. Wind is getting more and more integrated into the energy systems. That means that we need to work with more intelligent ways of integrating renewable energy. So we work a lot in the grid area and in the energy systems in order to facilitate and enable more integration of renewable energy into the grid. We work with aerodynamics because the more energy we can capture from the wind, the better it is. And of course, we work with the drivetrains themselves in order to make them more efficient and basically produce more with less. That is the point here. So, Vestas and sustainability, what is that? Well, when you talk about sustainability, you can talk about economical, social, political, environmental, technical sustainability. And Vestas as a company work in all these areas. What I will focus on now is the technological part and the environmental part. And as a company in 2010, we had 42% of our energy consumption coming from renewable energy and 74% from renewable sources of the electricity consumption. We have set a target for 15 where we say 55% of our energy consumption in the company has to come from renewable sources, and in terms of electricity, 100% has to be renewable. And why is the energy part not 100%? That's basically because it's not available to us in the region where we operate. If it was, that would be 100% also. We are building a new headquarter in Aarhus, and that will be the greenest building in Scandinavia. It will be LEED certified, and it has taken all the latest technologies in terms of making this building as sustainable as it is at all possible with known technologies today. We are part, in order to also, of course, work with policies and energy policies, we are part of different forums, the World Economic Forum, the United Nations, and also the Global Impact Lead. We are there as a participant also. And that is, of course, to work with the international and global policy in energy. We have also taken a new initiative in the beginning of 2011, and that was the introduction of what we call the Win-Made label. And we did this in order to empower you as a consumer to favor companies who work in a sustainable way. So you can make, as a consumer, your choice of which products and services you buy. Some of the partners in this are well-known brands, as you will also recognize from here. And I can tell you the list of global corporations who want to join this initiative is very, very long. So look out for this label called Win-Made. So, as I said, if you truly want to work with sustainability in your products and services, you need to start upstream. And it starts in the design when it comes to the products. And if you look at a typical value chain for our products, it is upstream in the product design and the way we validate our products and the way we test them. And let me be very, very specific in an example here in choice of material. But first of all, our approach when we do design these products is that we embrace the entire power plant that we're going to deliver our products to. We embrace the entire life cycle of the products. That means that we design in also how these products are going to be decommissioned, and we also embrace the entire value chain. That means that we involve our suppliers and also, you can say, the parallel industries supplying into the power plants. That is built into our design from the beginning. So this is a quite extensive process that we're going through. And when we put up turbines today, the expectation is that they are going to operate and generate electricity for something like 25 years. So you really have to think in what is going to happen over the next 25 years. So in the choice of materials and technologies, let me give you a very specific example of the criteria that we are setting up. One of them is energy density, and that is basically to make choice of technologies that are as efficient as possible. And in our case, it's how many megawatt hours they produce per weight unit. That is our expression of. In terms of sustainability also, we are looking for options that is producing as many megawatt hours as possible per weight unit. We do not accept the use of strategic raw materials, and I will give you a concrete example of that. So it is simply not built into our design, the use of what we call strategic raw materials. And one of them is, as an example, could be rare earth materials, which are used in a wide range of industries. It's used in hybrid cars, in iPads, smartphones, and so on. And there is a huge rush for many different industries to use these very scarce resources. But we make a decision, a deliberate decision, of not building these materials into our design. In terms of choice of technologies also, it is extremely important to us that it's reliable, that the operational cost of these technologies are very, very competitive, and also from a capital expenditure point of view, that it is very, very competitive. These are some of the criteria we use when we do choose technologies. As I said, one of the challenges here today is what we call the rare earth materials. There is a lot of different compositions of these materials, and it is a scarce demand today, but a huge supply situation. And this is basically a situation which is not acceptable to us, and it's not acceptable to our customers either, this situation. And also it makes basically the price and availability of these materials unpredictable in the future. So we have basically decided to design this out of the solutions. A very important point for us also is that new technology is more efficient. The ones of you here from Denmark will know that we frequently have debates about wind turbines. There are too many in the landscape and we don't like to look at them and so on. We also have to say most of the turbines we have in Denmark today will probably be retired within the next 5 to 10 years. And a new turbine today can replace 250 turbines which were put up 20 years ago, 30 years ago. So this is the technology development that we have seen over the last years here has made this possible. And basically, we have about 5,000 turbines in Denmark today. If we put up the latest technology onshore, about 100 turbines could replace 5,000 turbines. So that's what is possible today. So it is only willpower needed to do this. There is nothing else needed. So how does it look technically on a wind turbine? The carbon footprint, and I'll come back benchmarking this to other sources. It generates 7 grams per kilowatt hour. The energy that it takes to produce a wind turbine, the turbine itself has generated in 8 months. So it has paid itself in 8 months. And it is going to be out there for 25, 30 years. It's a very good payback to Mother Nature. The recyclability directly of a wind turbine is about 80%. And of course you need to ask, why is it not 100%? But that is in the definition of the standard in the way the recyclability is calculated, that some of the parts in the wind turbines needs to be processed before it can be recycled. So that is inherent in the definition. And we use 30 liters of water in the production of a wind turbine per megawatt. So how is this benchmarked to other sources? When it comes to carbon footprint, As I said, we use 7 grams per kilowatt hour. And I think I don't need to explain what is on the right-hand side. And I have to say, of course, I'm biased in this, so these are not Vestas numbers. These are international numbers. So if you want to be dumber, faster, choose from the list on the right, please. If you want a sustainable choice, choose from the far left. One thing which is not into the equation today, but will soon come because it is truly a scarce resource on this planet, is water. How much water does these different technologies consume when you generate electricity? And we have made a benchmark here also, together with some third parties, and wind and solar energy basically does not consume water when you generate electricity. Gas, coal, and nuclear consume enormous amount of water for generating electricity. This is not something which is discussed today, but I can promise you it will get on the agenda because these are dramatic numbers that we're looking at here. And drinking water is a scarce resource. So by being proud of copying a little bit, Obama said in his address here in January, instead of subsidizing yesterday's energy, let's invest in tomorrow's energies. I would say instead of investing in yesterday's technologies, as I just showed, let's innovate tomorrow's energy. So where does this start? But it basically starts by looking in the mirror, because you can make a change today. You can make the choice of what you do in your personal lifestyle. So I would say, look in the mirror and get on with it. So thank you very much for your attention.